And we're back. Okay, so let's get started. You wanted to see the build command.
Yes, I'd like us to start with the build command because build is such a central.
Do you want to start from the very beginning, like the entry point, the CLI entry point, or do you want to focus on the handler?
We can, because I'm not the only one, I think, who's going to use this resources. It makes sense to start from the beginning, just to make sure that whoever uses this can actually have like a full mental model of how we move from a command to a handler to the different flags within the commands.
Sure. And I'll fast track this part for now, and then we'll do a deeper dive on that part because we have about 45 minutes. So let me get started with the main application. So with DockerSlim, you have two applications. You have the main DockerSlim app, and that's the code, the entry point for it is located in the CMD DockerSlim folder. And then you also have the sensor that's located in the CMD DockerSlim sensor directory. And the sensor gets installed when the build command runs in the temporary container that it gets created. So for now, we'll take a look at the main app located in the CMD DockerSlim directory. And the entry point there is pretty small. Pretty small. It doesn't have much code. A few lines of code. It just imports the app package and it runs it. So let's explore the app package. So we have a couple of apps, the master app, the main app we have that you run on your laptop directly. And this is the package. And again, it's not a lot. It's pretty simple. And what it does, it creates a CLI object, and it runs the CLI. And it also sets up a few signal handlers. So what is that CLI? The CLI object is based on this CLI library, one of the two popular CLI library out there. And when we create a new CLI, we register the commands we want to have in the CLI app. And one of the commands is the build command. We have a whole bunch of imports in the commands directory, and one of them is build, and we'll explore what it looks like. But for each command, we show the intent that we want to use that command. You don't have to use all of them. So you can comment out one of those register command calls and it won't be included. But this is the first thing that happens. We register those commands, and when that happens, those commands, those packages, command packages, they add themselves to a global CLI collection that we leverage later on. And it's actually at the end of the new CLI function. So right there, there's this global CLI collection, and we use it for this CLI app object. When we set up the CLI app object, we provide a couple of callbacks. One of the callbacks is there to handle the cases when you type DockerSlim something something, and that something something isn't a real command. So there's a handler when there's no command but the name that you type. And then there's a bit of code to initialize the global flags we want for the app, for the main app. And then there's also a before callback that gets called before the commands, the selected commands, get executed. And in this callback, its primary purpose is to set up logging and other global flag side effects. There's one more callback. So when there's no command passed to the main app, then this action callback gets executed. And here if there's no command specified for DockerSlim, then it will start in this interactive CLI mode. And it'll use Go prompt to make it happen. And we'll explore what it looks like briefly. Let's see. Guess it's not here. Commands. So let's take a look at the commands folder. Yeah, this is what we do here. We use the Go prompt package, and we set up this interactive prompt app where we set up the data. We set up the prompt. We set up the command data that we want to show. Command completion, flag completion, and all of that. So what's interesting is not actually the common command code. What we care about is what happens in those register command calls and what happens when you select a command. So let's pick one of the commands, and right now we'll take a look at the build command. So for each command, we have a directory with its name, and they look pretty similar. For example, there's one for X-ray, and build. The file names look similar, and they're structured based on their function and purpose. So for each command, we might have a number of command-specific flags. There's a number of shared flags we'll be leveraging. Global flags and command-specific flags. For example, we use the HTTP probe flag in the profile and build commands. So it's a shared flag defined in the common section. But in the build command, in the flags.go file, we have the command-specific flags. For example, there's a flag to tag the fat image the build command can create. If you point the build command at a Docker file, it will create a fat image. So you don't need to run Docker build separate. You can build your fat image, and then you can optimize it. So in this case, you can specify an optional tag fat command flag, and we'll get to use it. So for each flag, there's also a usage constant, and we use that in the flag description and also for the interactive prompt. So right there, we set up a data structure we use for the CLI, where we say this is the name, and this is the user information, and this is the specify that flag, instead of using the command line argument. And then with those flags, at runtime, based on the type, you extract those flags from the context, from the CLI context, and that's all of that CLI package. So it's not DockerSlim specific. It provides the plumbing. And then there's also this CLI.go file. In that file, we set up the main CLI command structure that the CLI package needs. We describe the command we want to have in the application. We specify the flags, the application command flags for the build command. And some of those flags are the shared flags. For example, flag pool, that's one of the, or flag HTTP probe, one of the shared flags. And we also have the command specific flags. For example, flag tag fat that we just looked at. So it tells the CLI package that we want to have those flags for the build command. Some of the command descriptions are provided in line, and we need to clean it up, and we'll need to refactor that and put it in the flags.go file. And then for each command, in addition to providing the flags you want to support for the command, you specify the action callback when that command gets executed. So when you run DockerSlim build something something, then this action command gets called. So this is where you land. And in pretty much every command, we have a bit of common logic. We show the community information, the links where you can go to ask for help, ask questions. We also set up this execution context, and that's meant to provide this kind of interface between the main application and the command code that's running. So when you're when the command code wants to output an error, it would use the execution context for that I/O, as opposed to doing console I/O directly. That makes it possible to run the command not only in the CLI mode, but potentially in the server mode, where the I/O would be piped and delivered to other locations. And there's a number of I/O operations. One is error, another one is state update, and then there's a number of other things, message, information, and all. And in all commands, after we have that basic setup, we pull the flags we care about. And for each command, it will be command specific. But a lot of times, the commands point to a target image. And this target image can be specified either with a command line flag with a -- target value, or it can be specified as the last value of the command line. So we have a bit of logic to figure out where we have the target reference. And either way, we locate that target, and then we collect the global flags that that this command has, and if there's an error, we'll exit and we'll update the error information and the state information. And then we start pulling different command flags. And in some cases, the flag values are pulled directly, individually. Like here, the pull flag that you can specify to pull the image from the registry if it's not locally available. In other cases, we have helper functions that grab multiple related flags. For example, get container build options extracts the container image build related options, and these are the container build options you would specify to Docker build. Let's see, there's a lot of flags, and if you have any questions about the flags, I'll be happy to give an overview of what they are.
So far so good. Yeah, so far so good.
Okay, so I'll spend a couple of minutes on the HTTP probe flags, specifically the HTTP probe flag itself, the main flag, because there's a little bit of logic to figure out if probing is enabled or disabled. And it's important because by default, DockerSlim build tries to probe the temporary container, because it assumes that it's a server application. You can disable probing. There's a couple of ways to do it, but that's the assumption. And it it checks to see if there's if it can locate the port information, the exposed port information. And if not, DockerSlim build fails execution. It'll ask you to specify the exposed ports explicitly, which can happen if the Docker file that was used to create the image didn't have the expose instructions. So if that's the case, you need to use the -- expose flag, or you can disable probing, because you can, it's totally fine to use the build command for CLI applications. So here we figure out if HTTP probing is disabled, and one way to do it is to set the HTTP probe parameter to false. So you do -- HTTP probe equals false. Another way is to use this, a similar flag, but you can just say -- HTTP probe off, and they'll do the same thing. That way you don't need to specify the value for that flag. You just specify the name, and that's it. So either way, it turns off probing. And then you get a bunch of probe commands if there were any specified, because you can specify the custom probes. There's a lot of additional parameters that help you fine-tune how probing works, and you can pick and choose which ports you want to use. For example, your image might expose 10 ports, and you want to use only one, so you can focus the probes only to a subset of the exposed ports. And there's a helper flag that helps you control the behavior that I just described. Well, actually, that's a different behavior. So when probing is enabled, it runs the probes, and it needs at least one of those probes to be successful. And if it's not, it's going to fail. But you can disable this behavior, and you can say HTTP probe exit on failure equals false, and then DockerSlim will keep running. The next couple of flags are about getting the API spec information either from files or from remote endpoints, and that's Swagger specs. And then the probe component uses that information to auto-generate commands that it runs against the temporary container. Like I mentioned previously, it's very basic. We need to make it more advanced so it does a better job with the parameters, the query string parameters and the body parameters and the path parameters. And one of the new and recent additions to the HTTP probe family of flags is this HTTP probe exec and HTTP probe exec file flags. With those flags, you can invoke an external application when the probe is running. For example, I can run curl when the probes are running, and you can hook up any application to that flow. So it's a convenient way to connect the probing phase to whatever external plumbing you have. You might have a set of integration tests that you might trigger or something else when you're running the probing phase. I'll skip the rest. Oh, go ahead.
Yeah, what about situations where your container cannot be able to run effectively in isolation, so you need specific dependencies? So an example would be you need to connect to a database or a Postgres instance to be able to actually probe the endpoints. What do you do in those particular scenarios?
Good question. So there's an enhancement. There's an enhancement that's coming to DockerSlim pretty soon with native Compose support. But for now, you're expected to set up those dependencies separately. So I'm opening the examples repo, and here there's a couple of examples of what it looks like. So here, for example, we have this Python Django to-do app. With this app, we have the container image, the application container image, and we also have a Postgres dependency. So the application needs the Postgres database running. In this case, you need to start the dependencies. For example, in this case, I say Docker Compose up, Postgres. So now Postgres is running through Docker Compose. And let's see. And when we're slimming, here, can you see the text? Do I need to make it bigger?
The text is clear.
Okay.
Yeah.
Good. So here, when I run DockerSlim, I also need to specify a couple of extra parameters. First, there's this expose parameter, and it needs to be there because the Docker file, if we look at the Docker file, the application Docker file, it doesn't have an expose instruction. And if there's no expose instruction, then DockerSlim doesn't know what it needs to do, what port it should explore. So that's why there's an explicit expose flag. And then the most important part is this. So when you're using Docker Compose for dependencies, you start the dependencies, you need the temporary container that gets created to connect to the dependencies. And for that to happen, that temporary container needs to connect to the right network. So here you specify the network parameter, and you point at the network that gets created by Docker Compose. And then there's also this env environmental variable parameter, because the application needs the database URL environmental variable to know what it should talk to. So this is how you connect the temporary container that gets created to the dependencies that exist. So those dependencies that could have been created with Docker Compose, could have been created manually. So either way, you need to connect the plumbing. And obviously, it's extra work. And that's why that native Docker Compose support will be really nice, because you'll be able to point to the Docker Compose but the dependencies, and you won't need to specify the network manually, and it'll be a lot easier, and you won't need to run Docker Compose separately. So it'll be much easier. That's the intent. Does it make sense?
Yeah, it makes sense. The plumbing right now just looks very unfriendly, because you can imagine trying to connect to multiple dependencies. Think of
Yes.
maybe a container that is an orchestrator that needs to connect to maybe 5 different services, and you need to do the plumbing for that. It becomes a pain and something that you can easily miss. And during debug sessions, you might end up not actually find what the issue is.
Yeah. So if you start all of those dependencies separately, you definitely have to deal with a lot of extra friction just to connect to all of them. If you're using a single Docker Compose to bring up all of those dependencies, one network flag might be enough. But it's definitely extra work. That's why the native built-in Compose support is coming, and that's why native Kubernetes support will be next to simplify that, where you can where DockerSlim, the main app, can orchestrate the dependencies for you and then connect the plumbing. Yeah, that's not for beginners. So what I was just showing is not for beginners, because you need to know about networking and other things and etc. So definitely lots of room for improvement. So there's a bunch of other flags, and we can have a separate session on each major category. For example, the include flags. There's a lot of interesting stuff going on there, including permissions and overriding permissions and users and groups, etc. That's useful for a number of advanced use cases. One of the other important parameters is this continue after flag. So by default, continue after is set to probe. And what is continue after? So DockerSlim needs to know when the analysis phase, when the dynamic analysis phase is over, and when it should move on to the next phase. There are several ways to communicate that, and there are different modes there. Probing is one. So what does it mean when continuing after is set to probe, which is the default? It means DockerSlim build will run all probes and the related probe apps, and when it's done running those, that indicates to the main app that it's ready to move on to the next phase. It's done with the analysis, and it's time to collect the artifacts and do post-processing. There are a number of other modes, including enter. When you say enter, that means a human needs to press the enter key to continue. So that's kind of the most basic setup, where you rely on a human interaction to decide when the analysis phase is done. Another one is signal. You can send a Unix signal to DockerSlim based on your infrastructure setup to know that when it's time. And that's usually nice when you have some kind of out-of-band testing set up. So you run DockerSlim, and it runs its probes, and then you also run your integration tests out of band, and then you send a Unix signal to DockerSlim when your integration tests are done, and DockerSlim continues. There's also exec. So there we can, and that mode, continue after mode, works with the exec and exec file flags. Exec and exec file, they're like the exec command, docker exec command. When you run docker exec, it lets you execute shell commands in a target container image that's running. So it's pretty much the same thing. And there we can say, well, here's a bunch of shell commands to run using exec. Once they're done, it means we're done with analysis. And you can also combine exec and probe modes. So probing runs and exec commands run, and then analysis is done, and we can move on to the next phase. There's also a timeout option where you can say, I'm going to wait 3 minutes, and then after 3 minutes, I assume we're all good, and we'll continue.
So in what particular scenarios do you want to use exec as opposed to HTTP probe? Because you could end up using exec to do probing.
Yes, so there's an overlap potentially. For example, if you run curl with exec, but what happens, probing is done externally. So probing is done by the main app to the temporary container image. Exec runs shell commands from within the container image. So that's one of the major differences. And you are not limited to network probes. It's not just curl. You can do lots of different things. You can run any shell command. So there's a little bit of overlap, but you can do a lot more with exec based on its purpose, because it allows you to run any shell command from within the temporary container. But probing, that's done externally, and it's only network probing. So in some cases, people use the exec
that makes sense.
file with curl. Let's see what else. And here we grab the exec commands either from the flags or the file. And once we get all of those flags, we start the command. And it's located in the handler.go. So I'll quickly look at register.go. This is the function that it gets called from the main CLI code, where we say, hey, the build package, I want to register the build command. And when that happens, we add the CLI data structure, the CLI command data structure we set up in CLI.go, that one, to the global collection of CLI commands, which then we use to set up the CLI app. And we also set up the data for the interactive prompt. These two other things, that's what they're meant to do. And then the prompt.go file includes the logic that gets used by the interactive probe to provide suggestions for the flags and all of that in the flag values. And handler.go is where the main application command code lives. Yeah, it's a pretty long function. It needs to be refactored in a significant way. And here, the first thing we do, we set up a command report object. because when we run the command, we print stuff to the console, but we also collect important information in this command report. And then we save that, and it's one of the artifacts that's available to you. And in some cases, you get a lot more data in that command report JSON file. We also check to see if we have the current version for the app, which is pretty similar to how Terraform does it. They have a similar setup. Because we're working with containers, we set up a Docker client, and then we check to see if the command points to a Docker file. If it's the case, then right there, line 167, then we build the fat image first. So you don't have to run Docker build before DockerSlim build, because that's one of the patterns I've seen over and over again. When people shared their snippets, they would have Docker build and then DockerSlim build. So with this capability, you can just say DockerSlim build, point to the Docker file, and it'll take care of the first step for you. We have a basic image builder where we build the fat image from the Docker file that's referenced. Then we do basic network validation to make sure that the networks the network that's specified is a real network. Then we create an image inspector, and the image inspector performs a basic sanity check to see if the target image exists. And then it's used to do static analysis on the image. Then we process the static analysis data for that image. And one of the things we do when we do that static analysis, we try to reverse engineer the Docker file, the original Docker file. And one of the kind of additional insights, higher level insights we get from this static analysis is related to, well, actually, that's the X-ray command. But here we're also looking at the user information that gets used. The X-ray command does a lot more actually. So the build command runs basic static analysis, and the X-ray command is like this basic static analysis phase plus a lot more. And one of the refactoring goals is to combine the two, where you can say, guess what, do full static analysis and leverage the X-ray command code, because there's a little bit of duplication. So there's a lot of duplication across different commands. For example, the profile command and the build command, they're very similar, except the profile command doesn't build the optimized image based on the analysis results. Let's see. So once we're done with static analysis and we process the static analysis data, we create a container inspector object, and that object is responsible for creating the temporary container image, container instance, based on the target image that we reference. And it's also responsible for setting up the IPC between the main app and the sensor in the temporary container that gets created. And it's also responsible for inserting that temporary sensor, the sensor into the temporary container instance. It'll be good to take a look at that. we're running out of time, so I'll fast track and we'll do part 2. But I think just having a general idea here is good. So then we run that container inspector, and that's actually where the IPC setup happens, and we communicate with the sensor to communicate the intent and the command that we want to run in the image, in the container instance that we started. And then we run probes. So we set up the probe component with the parameters that we extracted from the command. And we run it. And this is where there's this extra logic to handle multiple continue after modes, where you can specify exec and you can specify probe at the same time. So we go through each probe that was specified. For example, we go through the each continue after mode. So let's say you specify probe and exec. The first time around in this for loop, we execute the exec commands, and then the second time around, we'll run the probes. And with probes, we will wait until the continue channel is signaled. Then after the analysis is done and we get the artifacts from the temporary container image, we'll do post-processing. We check to see if we have data, and then we process that data, and that data includes the container execution report, a JSON file, and it includes a whole bunch of files that we copied from the temporary container image. And that's what we do there. We process all of those results, and then we create an optimized image where we take. So one of the things we do when we process the results, process the collected data, we create a new optimized. We create a Docker file for an optimized image, and it gets generated as one of the artifacts, and you can see what it looks like when you go to the state folder for that execution, and you see that folder path in the CLI, and it's also there in the command report. So there we just create a brand new image based on the optimized Docker file and the artifacts we collected. And then we check to see if the image is there, and we get a little bit of information about that new optimized image. And then we use that to show how much we optimized it based on the original image and this new optimized image metadata. For example, right there, we use this execution context out info interface to show how much we minified the image. And we set up other command report fields, and we including the paths to different artifacts, including the optimized Docker file. And then we save the command, and we can also copy the artifacts to another location from the temporary state directory to the current directory, for example. And that's useful when you want to use the seccomp profiles. At least some of the helper apps nginx. Let's do third-party Nginx. So if we look at Slim, there's this copy metadata artifacts flag, and that's what happens here, where we take the copy from the temporary state directory and put them where you want them to be. And in this example, I'm just putting it in the current working directory because later on, I want to run this command, docker run security opt seccomp nginx seccomp.json. So I copied the artifacts to the current directory, and then I can reference them directly. So they're located in a known location. And then archiving state is useful when you run a DockerSlim Dockerized. Then you can archive it to a volume, and then when the Dockerized version of DockerSlim is done, you can grab the results from this archive volume. So it's available, it's not gone. Yeah, and then we just save the command report. So that's a high-level flow for the build command. And obviously what happens in the container inspector is also interesting in the post-processing phase, but at a high level, these are the steps the build command goes through. How does that sound? Does it make sense overall? Do we need more clarification for that high-level flow before we get to the next level of details? Okay, sounds like we're good, and we're actually out of time. And let's wrap it up, and then we'll do part 2 to explore the container inspector part of the build command and other things.